Okay, so we worked with rational expressions in the preliminary chapter, but now we're going to take those expressions and put them in an equation, okay? So they're called rational equations. So let's say I have something like 1 over x plus 2 over x plus 3 equals 3 over x squared minus 9, okay? So this is probably bigger than what we normally would do, but something like that. So you see these rational expressions in there, right? Well, there's a couple things. First of all, remember we talked about how there are certain things that x can't be because we're not going to let you divide by 0. So if I look at this last denominator here, that factors, right? X plus 3 times x minus 3, the difference of squares. And then these others, they don't factor. I just have a factor of x and a factor of x plus 3. Okay, what I want to point out though is that x, no matter what happens, x cannot be 0 because that would create a problem right there. You'd have 1 divided by 0 and that's not going to work. X cannot be negative 3 because that would be a problem here and it would be a problem over here. And x cannot be 3 because I can't have this be 3 and I can't have that be, or I'm sorry, 0. So when is that 0? If x is negative 3. And when is that 0? When x is 3. Okay, so I have 3 what are called excluded values. Excluded values. So in the end, when I'm done solving this equation, which I'm not going to solve this one, but when I got done, I'd have to check and make sure that my answers aren't 0, negative 3, or 3, because those are not allowed because it means dividing by 0 in the original equation, and I can't have that. Now, we can clear the fractions, so to say, by multiplying by the least common denominator, just like we did in the last video. So what you have to do is you look at it, you look at all your denominators and say, what would the LCD be here? Well, in this case, you would have a factor of x, you'd have a factor of x plus 3, and you'd have a factor of x minus 3. And that would be the LCD. So you don't need 2 factors of x plus 3. It only appears once here and it appears once there, but you only need 1. And then that would be the LCD. And you'd multiply each term by the LCD. All right, ours isn't quite as complicated in this example. And then we have, I think, 2 more examples after this one. So I look at this, it's a rational equation, it's got rational expressions in it. I look at the denominators, x, 5, and 2x, and I'm going to say, hey, by the way, note to self, x cannot be 0. That's the only thing that would make any of the denominators 0, so if x were 0, so I can't have x be 0. Then I'm going to find the LCD. In my LCD, I'm going to need a factor of x, a factor of 5, and a factor of 2. I don't need another x because 1's good enough. X only appears once per denominator. Okay, so my LCD is going to be 10x. I am going to take my equation and then everybody gets multiplied by 10. Each of those rational expressions get multiplied by 10. So here I am multiplying each rational expression by 10. I put the 10 in orange so you could see it. Oh, except I did it wrong. You're stopping and saying, wait a minute, why didn't she put the x in? My LCD was 10x, so I better slide the x in there. Ooh, it should be in orange. Put it in orange. Okay, it's in there now. All right, so let's see what happens. Now let me just go over that little error I made. It was 10x that we were multiplying by. So 10x, 10x, 10x. Each of these 3 expressions, each of them got multiplied by 10x. Now the whole point of multiplying by the LCD is to get the denominators to cancel. So this should be a happy moment for us. This x here is going to cancel with that x there. This 5 is going to go into the 10 2 times. This 2 is going to go into 10 5 times. And this x is going to cancel with that x. Okay, so it's messy. That's the messy step. What do I have left? Well, from here, I have 10. 10 times 1. Here, I have, now be careful, it's 2x. Notice that little guy didn't cancel, so it's 2x. 2 times 1 times x okay, plus, and then what do I get here? Well, the x's canceled out, right? So I just have a 15. Okay, now that's friendly to work with. That I can work with. So I'll go ahead and subtract the 15 from each side. And what does that give me? Negative 5 equals 2x. And I'll divide by 2. Turns out my x was on the right-hand side, but that's okay. Equations are, you can use the symmetric property of equality. So I can write negative 5 equals 2x, or I can write 2x equals negative 5, and that's okay. So what do I get for the answer? Well, I'm going to write x equals negative 5 over 2. And if you're thinking decimal, you could probably write it as a decimal, okay, but I would just leave it improper fraction. Okay,